Assalamualaikum and very good day to Dr. Ahmad Nazri bin Dagang. We are from Group 3. Would like to present our video about topic photodiode, LED and laser diode. I would like to introduce our group member. First, Nur Amira Masurina binti Fazil, Muhammad Syafiq Irfan bin Ramli, Muhammad Ashraf Azizi bin Ismaun, Muhammad Safwan Azizi bin Ahmad Zulfar, and me, Ahmad Hanif bin Muhammad. In this video have 3 parts. First about introduction, second about function, and about working principle.
Hi, I'm Amira. So I want to introduce electronic device. What is an electronic device? Okay, the electronic device is a device that delivers a single task. And an electronic device use electricity, battery or both. Electricity and battery. Okay, example of electronic device is camera, electric fan, microwave oven, car, and electric iron. Next is a photodiode definition. What is a photodiode definition? A photodiode definition is a type of semiconductor diode that serves as a photodetector. And the purpose of a photodiode is to convert power from photon of light into electric current. And the generation of electric current is occurred when the power of photon of light is absorbed by the surface of a semiconductor. And a negligible electric current is also generated without the participation of a light source. Okay, the right side is an example of a symbol of photodiode.
For the function, a photodiode is a PN junction diode that produces an electric current by consuming light energy. And photodetector, sometimes known as a light detector or photosensor, is a device that detects light. Photodiodes are made to work in a reverse bias environment. Silicon, germanium, and indium gallium arsenide are common photodiode materials. First, photodiodes are commonly utilized in everyday application. The linear response of the photodiode to light in radiation is the basis for its right use. Second, electric insulation is provided via photodiode and optocouple. Optocouple are used the optical couple to separate circuits when they are illuminated by light. When compared to traditional device, optocouple are faster. Third, photodiodes are utilized in a fire and smoke detector among other safety gadgets. Fourth, photodiodes are employed in a variety of medical settings. They are utilized in a sample analyzer, computer tomography detector, and blue gas monitor among other things. 5. Solar cell panel contain a photodiode. 6. In a logic circuit, photodiode are employed. 7. In the detection circuit, photodiode are used. And the last, character recognition circuit use a photodiode. Okay, principle. A photodiode is subject to photon in the form light which affect the generation of electron hole a pair. The energy of the falling photon is greater than the energy gap of the semiconductor of material. Electron hole pair are occurred near the depletion region of the diode. The electron of a pair create a spread from its order before it combine to the electric field of the junction. The direction of the electric field in the diode force the electron to move toward the N side and consequently the hole move toward the P side. Under that, as a result of the increase in the number of electrons on the N side and hole on the P side, a rise in the electromagnetic field is observed. Now, when an internal load is connected to the system, a current flow is observed through it. The more the electromagnetic field, the greater the current flow. Then, the magnitude of the electromagnetic force depends directly upon the intensity of the incident light. The effect of the proportional charge in photocurrent with the charge in light intensity can be easily observed by applying a reverse bias. Photodiode generate current flow directly depending upon the light intensity received can be used as photodetector to detect optical signal. Built-in lens and optical filter may be used to enhance the power and productivity of the photodiode.
For this part, I will explain about light emitting diode. Light emitting diode is a semiconductor device that emits light when an electric current flows through it. When current passes through an LED, the electron will combine with host emitting light in the process. LED allows the current flow in the forward direction and blocks the current in the reverse direction. And lastly, light emitting diodes are heavily doped p-n junction. In the LED symbol diagram, the LED symbol is the standard symbol for a diode, with the addition of two small arrows denoting the emission of light. And lastly, the color of an LED is determined by the material used in the semiconducting element. For the main function of an LED is to convert electrical energy directly into light, delivering efficient light generation with little wasted electricity. For the next function of an LED, the LED emits light when an electrical current passes through it. The simplest circuit to power an LED is voltage source with a resistor and an LED in series. The simple LED circuit with resistor might be used as power on indicator for a DVD player or a computer monitor. Next is LED are found in various fields such as optical communication, alarm and security system, remote control operation and robotics. It is found usage in many areas because of its long-lasting capability, low power requirement, swift response time, and fast switching capabilities. Most standard uses for LED are for dimming lights, used in automotive display and TV backlighting. Next is about the working principle of an LED. For the working principle of an LED is the energy is released in the form of photons on recombination. It is called phenomenon electroluminescence. Electroluminescence is an optical phenomenon and electrical phenomenon where a material emits light in response to an electrical current passed through it. As the forward voltage increases, the intensity of the light increases and reaches maximum. When diode is forward biased, the minority electrons area set from P to N while the minority holes are set from N to P. At the junction boundary, the concentration of minority carriers increases. The excess minority carriers at the junction will combine with majority charges carrier.
Semiconductor-based device that generate a coherent, monochromatic and highly directional beam of light when a current is passed through it. It is a compact, efficient and cost-effective light source that has a wide range of applications in various fields such as telecommunication, data storage, industrial automation, scientific research, medical and consumer electronics. A laser diode is composed a small cavity or resonator that contains the active material, typically a semiconductor crystal or a composite material. The active material is designed to emit light when stimulated by an electrical current. The active material is placed between two mirrors, one of which is partially reflective, and other is highly reflective. The mirrors are used to form a standing waveform, which causes the light to be amplified and emitted in a single highly collimated beam that is called laser action. The emitted light has a specific wavelength, usually in the infrared or visible spectrum, and it's characterized by high coherence and monochromaticity, meaning that it is a single color beam and the waves are in phase with each other. This property makes the laser diode very useful tool for a wide range of applications such as high-speed data transfer, data storage, industrial automation, medical, scientific research, measuring, and many more. Additionally, laser diode can be modulated, meaning that the output light can be turned on and off quickly, which makes them useful for application such as data transmission and data industrial automation. It also can be used in barcode scanner, laser printer, laser pointer, laser sight for firearm, and many other applications. Main function of a laser diode is to generate laser light. This is achieved by passing an electrical current through the active material of the diode, which is typically a semiconductor crystal or composite material. When the current is applied, it causes the electron in the active material to jump from a lower energy level to a higher energy level, releasing a photon in the process. The active material is placed between two mirrors, one of which is partially reflective and the other is highly reflective. The mirrors are used to form a standing wave pattern, which causes the light to be amplified and emitted in a single, highly collimated beam. This is known as laser action. The emitted light is characterized by its coherence, meaning the light waves are in phase with each other, and it is monochromatically, meaning it consists of a single wavelength. These properties make the laser diode a very useful tool for a wide range of applications, such as data storage, telecommunication, industrial automation, scientific research, and many more. Laser diode can also be modulated, meaning the output light can be turned on and off quickly, making them useful for applications such as data transmission and industrial automation. Based on the process of stimulated emission of radiation, this process occurs in the active material of the diode, which is typically a semiconductor crystal or composite material. The active material is placed between two mirrors, one of which is partially reflective and the other is highly reflective. The mirrors are used to form a standing wave pattern, which causes the light to be amplified and emitted in a single highly collimated beam. When an electrical current is passed through the diode, it is causes the electron in the active material to jump from a low energy level to higher energy level. As the electrons return to their original energy level, they release a photon of light. This process is known as spontaneous emission. However, when a photon of light interacts with an excited electron, it can stimulate the electron to release another photon of light with the same phase, wavelength, and direction as the original photon. This process is known as stimulated emission. The standing wave pattern created by the mirror causes the stimulated photon to be amplified and emitted in the same direction, creating a highly collimated beam of light known as a laser light. This process is called laser action. The emitted light is highly directional, meaning that it is emitted in a single, highly collimated beam. The wavelength of the light also highly consistent, meaning that it is monochromatic. This is because the active material and the mirror are specified and designed to produce a certain wavelength of light. In summary, the working principle of a laser diode is based on the process of stimulated emission of radiation, which occur in the active material of the diode. The active material is placed between two mirrors, which are used to form a standing wave pattern that amplify and emit the light in a single, highly collimated beam. This process is called laser action.
For conclusion, have three. First, about photodiode. Almost any electrical equipment can be modified to use photodiode. which are optoelectronic devices with a wide range of type and application. They are compatible with infrared light source such as laser, LED, neon, and fluorescent light. Additionally, they cost less than many light detector diodes. Second, about LED. The IV curve of LED, which a tiny point light source enclosed in the plastic dome. It's asymmetrical. They are generate colorless light, has narrow band spectrum. The color an LED emits is colored which is on voltage. Additionally, LED may either convert light into electric energy serving as load in an electric circuit, or because they are made of a semiconductor material. And last, about laser diode. Semiconductor laser diode have been around for about 40 years now, but their possible use continue to grow up each day. Laser diodes are semiconductor devices that produce light by optical application and electromagnetic radiation induced emission.